I know it's just after lunch, and people think that it's now time for siesta, but we are going to enjoy a really nice talk about OpenTelemetry. My goal for today is like, maybe you know about that tool, maybe you not, but you're going to learn about it, and you're going to know how you can adapt to your company, how you can adapt into your product and make it use. So let's get started. Antonio Jímenez, coming from ThousandEyes Cisco, and today I'm going to talk about OpenTelemetry. Okay, for the agenda today, we are going to have a quick introduction about that tool that I just mentioned. About ThousandEyes, I want to talk briefly because how we have adopted in our company, so you should know a little bit about the company, of course. And then we are going to jump into the architecture, into the details about how we have done it and how it is working. And then, of course, we cannot talk about the architecture without talking about the challenges that we have faced making that. We are going to end up with a nice demo explaining how everything works. Okay, so OpenTelemetry. It is an open source framework to manage telemetry data. It is a collection of APIs, SDKs, and tools. OpenTelemetry allows you to instrument, generate, collect, and export your telemetry data. Nowadays, everyone is talking about traces, metrics, and logs. Those are the supported signals. But of course, we have other signals like profiling, which they are working on, and most likely they will be soon part of the standard. I really like that picture because, in my opinion, describes what OpenTelemetry is. So in that side, you have like all the applications. So if your application is written in Java or in Python, using a Spring or Django or any other tool, with OpenTelemetry, you're going to be able to instrument it. There are two ways to do that: automatic instrumentation or manual one. You can even combine both. And then with OpenTelemetry, you're going to generate the data, you're going to collect it, and you're going to export to all those observability backend that you have there, any of them, anyone that supports the standard, you can export it. So here we can find out Jaeger, Zipkin, Prometheus, or any other. So the way how I see it is this the glue between your application and your visualization tool for monitoring. Cool. So now you know what is OpenTelemetry, but where we are going to focus today is on the collector. This is one of the main tools and most used for the people who develop using that standard. The collector is divided by 3 pillars. Okay, we have first the receiver, processors, and export. The good thing about the collector is it is flexible enough that you can configure it and you can make it in your own for your requirement for your system. In the receiver, you're going to be able to receive data from any format like OTLP, which is the OpenTelemetry standard format, but also another proprietary one like Jaeger, Prometheus, or even reading from your database or querying a WebSocket or calling an API. You can get the data from whatever you want. Then you can have, and this is done in parallel, okay? This is important because you can ingest data from different sources in parallel time. And then you're going to have you're going to have the processor. Those are in sequential, so one after the other, so the order important. And here we're going to have different ones like batching. This is important to group data together so you can export more efficient. We also have like attribute. That is another interesting one because you can enrich your data, adding extra attribute to your data points. And another interesting one is filtering. That allows you to filter out data points that are not needed to be sent to the customer. Like imagine they are considered old, or they have customer information that you don't want to provide to the observability backend, or any other decision. And now we arrive to the exporter. Of course, you need to export your data to your observability backend. And here, as in the receiver, you decide the format, the protocol, and the tool that you're going to use it. You can even create your own, as we have seen before. We also have the extension part, which is it's shared between all the 3 pillars. And here we have like health check or preprof for general things. Okay. Now we are going to jump into ThousandEyes. So what we do is we monitor the network. That might sound broad, but it is what it is. So we detect when an application like GitHub or AWS or any other around is down. And we notify the customer in milliseconds. And we also notify when it is down. It is down in the state or India, Spain, whatever. As you can imagine, we have agents all around the world. We have agents provided by us, but also in the customer side. inside of their own infrastructure because they want to know when there is a problem inside of their systems on their infrastructure. And then all this data is in real time because imagine you have a big application and it is down, you want to be the first one knowing about it, not your customer bothering you. This is a ThousandEyes network test, and here what we are doing is running periodically those tests, and the data is accessible through two places, through the dashboard as you have seen here, and also through an API. The data that we are collecting is varied from latency, page load, loss, throughput, and many other metrics that we gather. And just to have you a rough estimation, we have around 30K data point per second, which might sound not that much, but if you think how big is that data, it is huge. Perfect, now you know the introduction. Let's jump into our motivation to use OpenTelemetry. You cannot know the motivation without knowing the prior art. So our telemetry data is only accessible through a REST API and through the dashboard. So our customer, to enrich that data, they need to create their own integration, pulling that data periodically. And we don't want that. We want to make our customer life easier. The format that we support today is JSON. As you can see in that example, we are querying a test data, and we are getting like loss, latency, the agent that is running that test, and so on. So what are our motivation? OpenTelemetry is widely adopted industrially, so we are not the only one using it. There are plenty of integration, plenty of companies taking advantage of, so we want to also be part of those. And also it is vendor agnostic, which means that there is no a company behind. As I said before, it's a set of companies providing and collaborating to make it that work. It's a standard. And what are our goals? We want to make our integration easier, so we just want the customer to start receiving the data without pulling the data periodically. So it is a push API now, and of course, it is in real time. We cannot talk about the architecture without talking about our data model, so let's jump into that. We already know the test data. It is done through a dashboard or through an API. Perfect. And now we are going to a new concept, is the tag. It is a way to group tests based on a key value pair, okay? And you might think, why do we need tags? We need it for the integration. So an integration is a way to say which test data you're going to send to each customer endpoint. Perfect, so you have the tag match with group the test, and you have the string endpoint URL, which is your target endpoint where you're going to send the data. In that case, it's Grafana. And of course, you're going to need an authentication header to send that data to Grafana and make it work. And last but not least, you also have the endpoint type to send the data using HTTP or gRPC. Perfect. Now you know the data model. So let's see how is the association done. So you have the test associated with the tag and associated with the integration. Cool. Now we are going to talk about our architecture. We are receiving the data that the agent is generating from Kafka, and then we are going to have a metric collector, and that metric collector is going to receive the data, process, and export to the integration collector. In the integration collector, we are going to do the same flow, so we are going to receive that data, we are going to process and export to any observability backend configured by our customer. We also have here the metadata service, which is the one enriching that data that we have. Awesome. Now let's zoom into that architecture and go component by component inside of those collectors. You might be already thinking, why do we have two collectors instead of just one? The reason is because domain model. So each collector is for a domain. So we have the metric, which is for processing the metric. The integration collector is to design to which data point go to each exporter and to each observability backend, its target. And also, they are going to scale at a different pace. It means that the metric collector is going to scale depending on how much data you're receiving, and the integration collector is going to scale depending on how many integrations the customer is creating. Now we are going to zoom in again, and we are going to go component by component. So we are receiving the data from Kafka. In our Kafka receiver, it is a component of our collector. And now we are filtering out. Why do we need to filter out? remember, we said real time. Imagine that there is Kafka lag. Many of you might have an escalation because of that problem. Of course, we don't want to send data that is all to the customer, so we need to filter out here. We also have our attribute processor, which is doing enrichment of that data. And we also have a batching to group data points together, so when we export on the OTLP exporter using gRPC, we are more efficient. You can see on the downside extensions. I will go to them in details later. Now we are going to see the integrations collector. Here we are going to receive the data from the metrics collector using also our OTLP receiver using gRPC protocol. And in the integration processor, what we are going to do is, okay, that data point is going to be sent to 3 observability backends configured by the customer. So we are going to replicate that data. And in the exporter, in the OTLP routing, we are going to say, okay, that data point is going to that observability backend, like Signal. And that data point is going to go to Grafana. And that data point is going to go to another observability backend. The 3 data points from the same customer, but in the integration processor, what we are going to do is that replication. I will go in more detail later on. And now, I want to finish the architecture with the extension that we have. Between the extension, we have the health check. This is to know if our collector is ready to start ingesting and processing data. This is also quite useful for Kubernetes to know if the pod is initialized or not. Also, in the storage one, we are gathering data from the metadata service, saving into the storage, and that data is accessible through all the components of our collector. And I will explain that also later. The event bus is a PubSub system that allows you to send event and receive from other components. In mind, the metrics extension is receiving that event, and then it is incrementing a metric. The Sentry, as you might already imagine, we are catching every error and sending to the Sentry framework. And metrics, we need also to observe our observability system, of course. So we are gathering metrics for data point sent, data point failing, data received from Kafka. So all those metrics are important to understand our observability system. Of course, that architecture that might sound great, but we run through many challenges that I want to display them today. Data transformation is one. Remember, we received the data from Kafka. It is in a ThousandEyes proprietary format, and we need to convert it into a OTLP. That requires a transformation. Dynamic metadata. Imagine that you are creating an integration. You want to do it at the same time you want to already receive your data. So we need to adapt to new tests, new tags, and new integration to start exporting our data to Grafana, Splunk, or any observability backend. Multi-tenancy is quite important also. All our data is going through the same pipeline, and we have customers from different companies receiving that data. We need to make sure that we always send the data to the specific customer. Health and liveliness, it is also important, as I explained before, to know when the pod is ready. Sentry, to gather any error in a single place. We send all our errors to Sentry, an exception. Scalability is important. As I mentioned before, we need to scale based on how many integrations are created, on how much data you are ingesting, not only on CPU and memory, as we are get used to see. And last but not least, we have also observability. We observe our system, which means that we are having traces, logs, and metrics of our own system. For the sake of the presentation, we don't have time for all, so I will focus on those 3. Data transformation. We need to transform network test data into an OTLP format. As you can imagine, each test type is going to have a different structure and a different way. So some of them are in JSON, other in protobuffer, and so on. And all the data is flat, which means that the loss, the jitter, liveliness, all of those are going to be in the same place. And now we have also different attributes for each one. How are we going to solve that? We are going to do it using Kafka and different marshaller for each one. Awesome. So here we have an example, really nice. We are receiving data from the ping test, and using the ping and marshaller, we are able to extract that data in different data points. The same for HTTP, For HTTP, we have a HTTP and Marceller to send that data. And the same for endpoint tests. The endpoint test, the difference is like it is in JSON and the other one were in gRPC. So different and Marceller for each test type. This is an example how our data point look like. So we have name, description, unit, and many other things like the timestamp and a list of attributes. The second challenge that we have faced was dynamic metadata. So we need to be able to associate the test with the target at real time. So we need to be able to ingest that data in real time. And of course, that data is not complete, so we need to enrich that data. Imagine that you're receiving test ID. You need to add the test name, test type, and many other things. The way how we are going to solve it is using a storage extension, which is going to query the metadata service periodically to get that data and save it in a key value format, which means, for example, test ID and the object of the test, agent ID and the object of the agent. That storage extension is shared through all our components on our collector. Here you can see a really nice example where you are receiving 2 data points for the PIN, but with different test ID. Test ID 1234 and test ID 4321. And as you can see here, we have our integration storage that say that test ID is associated with those 2 integrations. Means that the filter processor is going to allow the first the first data point to go through, but not the second, because the 4321 we are not going to export it to any customer. Why do we want to continue processing? Cool. Now we are in the enrichment processor. Here, as you can see, we have agent ID 60. So we are going to add the attribute agent name and agent location. It is an enricher. The last challenge that we have faced was multi-tenancy. All our data points go through the same pipeline. So we need to make sure that the data is always sent to the correct target. Why it is important? Because there are some data that is, and some agents that are running inside of the customer infrastructure. So we cannot share with other customers like IPs, MACs, or result of their monitoring system. We are going to solve that using the concept of tenant aware. So an integration, a tag, and a test are going to have the same account ID, which means that they are going to have the same tenant. And then we are going to have our router exporter, which decides to which place each data point goes. Here is also a good example using the data point from before. So we have our PIN test data with test ID 1234 that is going to go in the replication processor. Here, that test ID is going to be sent into 2 integration, means that it is going to be replicated, plus we are going to add the integration ID. Now, in our router exporter, what we are going to do is decide, okay, that integration ID go to the exporter 1. So we are sending that data to that exporter. And the other integration ID go to the exporter 3, which is using even a different protocol. And that one is sending the data to its target. This is how we make sure that multi-tenancy works. And now, without further ado, I want to do a demo. In the demo, what we are going to explain is like we are going to, the architecture that I saw, I want to be able to make it work. So we are going to have a test, a tag, and an integration, and we are going to see the data in Grafana. Let's get started. We are going to create our HTTP test pointing to Google, and here you're going to be able to see the test ID. Perfect. Now we are going to create our network test that is also going to point to Google. Different tests are going to gather different metrics with different attributes. You will see later. And now we are going to have our tag. It's just created. Perfect. And now we are going to associate the test IDs to the tag. This is in that step, so we just copy the tag ID. Perfect. And now we are going to copy the different test IDs to associate it with the tag. We are copying the one from HTTP server. Cool. Now we are going to copy the one from network test. We are going to associate it. And now we click on send. Great. Now we have our 2 tests associated with the tag. And now we are going to create the integration. The integration is have the tag and have also the URL to Grafana and the custom header to Grafana token. Cool, and this is our integration ID. Now we are going to be able to see that data be able to get that data through the API call. So if we have the test ID, we're going to be able to see the test name, the agent that is running that test. We're going to be able to see also like response code and many other things like wait time, connection time, all those data that is getting from the API. This is for the HTTP test. And now we are going to go to the network test, same flow. We are going to gather all the results for our API. So the test ID, test name, agent, and many other. Let's move that thing. And now, the most important, the data is going to be able to send to Grafana. We can send to any observability backend. Just choose Grafana for the sake of the example. So here we have HTTP test. We have throughput, response times, and availability. And we are also going to have, as you can see already, the data is there. It's being received for that test ID. And we're also going to have network tests, which we're going to have latency, loss, and jitter. Those, remember, were metrics with different attributes that were in our ThousandEyes platform, and now we are streaming to other observability backend, and this example in Grafana. Okay, the demo take a couple of seconds more, but let's move it. So I want to close the presentation what we have learned about OpenTelemetry and this project. The standard is limited, which means that we have our metrics, logs, and traces, and they have their fields, but we're going to add more things. Implementing and creating a new custom component is quite challenging. But once you have it, making it work is super easy, and make it work with the whole infrastructure of the collector is easy. The community provides you a lot of components which are already built in, so you can extend easily each of them. We have done it with the Kafka and Marceller. And the community is quite helpful. That allows you to make questions. We have even contributed to the OpenTelemetry collector repository, solving a couple of bugs. So they are nice. You can access them on GitHub, Slack, or any other place. With that, I want to conclude the talk. Thank you so much for your time. I know it was tough, but I hope you enjoyed that. Thank you so much, guys.